It is finally happening. Today, I'm going to be building out a simple to-do list in TypeScript, and this is a perfect beginner project. We're going to be going over how to get started with TypeScript, all the setup steps you need, what you need to watch out for, as well as how to build the full to-do list application. Welcome back to Web Dev Simplified. My name is Kyle, and my job is to simplify the web for you so you can start building your dream project sooner, and today we're going to be covering TypeScript and this to-do list application. To get started, I have just really simple HTML set up. So I have an empty list, and then I have a form that allows me to add things to that list when we write the JavaScript. And inside the list, if we just put something, for example, you can see that that's what it's going to look like. Super basic, but that's just because we don't really care too much about the HTML. We're really going to focus on the TypeScript and JavaScript portions of this application. So now if you want to get started with TypeScript, the very first thing you need to do is to actually download and use TypeScript. So what we want to do is just run npm init, and you can pass -y to get all the default options. Now, if you run into an error when trying to run npm where it says you don't have npm, you need to first make sure you download Node. I have a full video covering how to do that. I'll link it in the cards and description for you. Once you've done that, you'll see that you get this package JSON file, and here's where you can put everything for your dependencies and your scripts inside of. So what we want to do is download TypeScript. To do that, we can type npm I. That'll allow us to install something. We want to install it as a dev dependency because it's not required for production. And then we can just type in TypeScript. So we hit enter, and that's going to download everything you need to do with TypeScript. And you can see here it's in that dev dependencies list. Now, in order to use TypeScript, we need to have a config file for TypeScript, and there's a tsc command that comes with TypeScript you can use. So since we've downloaded this inside of our project, we can use npx to run commands inside of our project, and that tsc command comes with TypeScript, and we can just say --init and hit enter. And that's going to create us just the boilerplate tsconfig file. And as you can see, this is a pretty lengthy file, but for the most part, everything's commented out. You just have a few default properties that are set. Otherwise, all the other options, you can kind of see what they are and what they do, and you can change them as needed. For now, we're just going to leave this as is because it's going to work for our use cases. Now, in order to work with TypeScript, we of course need to create some files that we're going to convert from TypeScript to JavaScript. And generally, you'll see something like this. You'll have a source folder, and inside that, you're going to have some JavaScript files. You'll have some TypeScript files. Let me just rename that real quick. There you go. So you're going to have TypeScript files, 1, 2, 10, doesn't matter, as many as you need. And then generally, you're going to have some kind of destination folder called dest, where all of your TypeScript files are going to be converted to JavaScript and put inside of. But by default, TypeScript doesn't quite work that way. Let me show you. If we wanted to run TypeScript, what we can do is we can create a script. We're going to call this script start. And this start script is going to run that tsc command, but it's going to run it with the watch flag. All this is saying is that every single time we make changes to our TypeScript files, as long as this is running, it'll automatically recompile our files for us, and we don't have to do it manually every time. So now if I just run npm start, which is that command we just created, it's going to run tsc with that watch flag, and it's going to take my TypeScript and compile it into normal JavaScript. So if I just say like console log I, for example, and I look at the script, you can see that it outputs this as JavaScript. So it's converting it from TypeScript to JavaScript. Obviously, for this use case, not much changes because it's just plain JavaScript, but you can kind of understand how that'll work. You will notice, though, that this script file is just placed right inside this source folder. In order to change where this gets output to, there's a option called out dir for directory. We can change this to be the dest folder. Now what's going to happen is all of our script files are going to end up in this destination. So if we just delete this, you can see now our script file is placed inside this destination folder every single time that we make changes. So if we come over in here and we change this to hi2 and I save, you can see the destination now has that automatically. And all we need to do is take our index.html and we need to import that script tag. So we can just say script here, which is from our dest folder, script.js, and we're just going to defer that for now. So now all of our JavaScript that we write inside TS file here, this TypeScript, gets converted into JavaScript here. And if we just inspect our page, you'll notice, I bring over the console, it's printing out hi2. So it's going from TypeScript into JavaScript, and that JavaScript file is being imported into our HTML here. Now this is great and is going to work for some really basic TypeScript setups where you just need to write some simple TypeScript, convert it to JavaScript, and use it in your application. But oftentimes when you're using TypeScript, you're also going to be having a more complex application where you're downloading libraries from like Node modules, for example, and this setup does not work if you try to install libraries inside your Node modules folder. Let me show you what I'm talking about. We can come in here and we can just download a library called UUID. And we're just going to give it a second. It's going to download. It's going to be inside our Node modules folder. And if we look in our package JSON, we now have a dependency for UUID. And if I go into my TypeScript file and I just say import, before as UUID v4 from that UUID library, and I save. We can just ignore this error for now. You're going to notice when I go over to my script, you can see that it's converted it to this kind of syntax format. This is called common.js, but there's a huge problem that this is actually going to throw errors. If I inspect my code over on the right, see, if I look at my console, you're going to see we get errors. What you could do to get around this issue is you could go into your TypeScript config, and what you want to change is you want to change this module system to ES6 instead of using common.js. But you'll notice when we look at our JavaScript here, it's now using import export, and if we make our code actually do something, so if we just call that UUID v4 function, and we look over here, you can see it's trying to import this from UUID, but again, this is going to give us an error inside of our console, and that's because the browser doesn't know how to access the node modules folder. You need to use a bundler in order to bundle up your node modules and your other code, and so that the browser can actually understand it. So that's one issue with TypeScript. If you want to get a little bit more advanced, you can't do it with just plain TypeScript without a lot of workarounds. So generally what you're going to want to do is go to a bundler. Now there's tons of bundlers out there for you to choose, such as like Webpack or Snowpack or Parcel. Personally, I think we're going to go with Snowpack for this because they have a really easy way to get started with TypeScript. So what I want to do is pretty much delete everything we have, and I'm just going to run this command for starting up a Snowpack project using TypeScript. So in order to do that, first, we just want to delete everything that we have so we don't have to worry about overwriting any of this. And then down here, I want to run npx create Snowpack app. And I want to create this app in the current directory, so we're just going to use this dot syntax. I want to use a template, and the template is going to be this Snowpack template for TypeScript. So we can say Snowpack /app template blank TypeScript. And now if I hit enter, now you will notice there's an error. It's just saying, hey, you're trying to use this inside your current folder. I just want to use -- force to allow it to use it inside this current folder and overwrite everything that's inside of it. So now what's happening is it's downloading all this code from this template, and it's going to put all of that code inside of here. As you can see, it's adding a bunch of code. It's downloading all of the dependencies. And now we have a bundler, which is Snowpack, set up with TypeScript. So now if we need to use node modulars, for example, it's going to know how to bundle that all together so the browser can understand what's going on. So we just give it a couple more seconds here, it should install everything. And if we look in our package.json, you'll see we have all of our dev dependencies down here that it comes with by default. So this is things like Snowpack, for example. We have Prettier, we have TypeScript, and so on. We also have one dependency just shown as an example here. And we also have some scripts. Our start script will start up our server. The build script is going to build and compile this, so when we deploy it for production, we can use this build command to make it just a more condensed version for production. And then we have format and lint, which we're not going to worry about, so we can just get rid of these and this test, for example. All we really care about is start and build. We can save that, and what we can do is we can just say npm start. What that's going to do is it's going to start up the Snowpack server, and if we open up this local host, you can see right here, this is just the boilerplate template for our Snowpack application. Now real quickly, we can kind of go over what's all inside of here. You can see we have that same ts config file right here. It's got some other changes to it to work with Snowpack, but you can make changes to this as you need if you want to, change how this works. Also, we have a Snowpack config, which has specific configurations for Snowpack. Most of it's pretty blank. There's not too much to it. We also have over here a Prettier RC file. I'm just going to get rid of this because I already have Prettier in VS Code. We have this types folder here, which we can put different types for just custom file extensions. So if we want to have like modules.css and so on, we can use this types folder for that. It comes with a lot of built-in ones. Don't really have to worry about that too much. We have source, which is where all of our code is going to go right now. This is just some placeholder code we can get rid of. And then we have public, which contains things like our favicon, which we don't need, some CSS, which we don't need, logo, which we don't need, and we have our index.html. What I want to do is I want to replace this with my own index.html. So what we can do is just paste in our own HTML, just like this. So this is the HTML we were using before, and we need to make sure that we import the JavaScript that we're using, our TypeScript. So if we go back and look at this HTML, you can see right here, it's using a type of module, and it's giving a source as dist/index.js. So let's just make sure we use that ourselves. We can have a script with a source of dist/index.js, and a type here is equal to module. There we go. So now we have anything inside this index.ts. So if I just console.log hi, that should show up inside of here. So I can inspect, go over to our console, and you can see it's printing out hi, which is working fine, and it's compiling that into its own script. Now, if you remember, I mentioned the fact that the reason we did this is so we can use node modules. So let's come in here and we're just going to install the UUID module that we had tried to install earlier. I'm going to say import v4 as UUID v4 from that UUID library. I just want to use that function. This should give us a unique ID. And we're just going to say console.log out this ID. So now if we save and I inspect my page and I come over to the console, you can see it's now printing out that unique ID for us. So this is working just like we expect it to, and we don't have to worry about that weird module stuff what we were worrying about before where it wasn't able to import from node modulars, and all of that is because we're using a bundler. In our case, we're using Snowpack, but you can use any bundler you want. Now, once you have that done, you can actually start writing your code. So there's a lot of setup that you need, but for the most part, all you have to do is run that Snowpack create app function, and you're pretty much right there ready to go running your code. So now what I want to do is I just want to go back to our other terminal, which is having that script running, so we can see if there's any errors that show up here. For now, I'm just going to comment this out, and then what I want to do is I want to write all of the code for handling this simple to-do list. So really what we want to do is we want to be able to select our elements, and our elements here, as we can see, we have our list, we have our form here, as well as our input itself. So let's select those elements real quick. We can say, for example, our list is document.querySelector. And I want to get the item, which is the hashtag list. So it's got the ID of list. If we look over here, you can see there's an item with the ID of list. And when I click save, you can now see we have that. We are getting an error, and this error is because we're not using import or export anywhere inside of our project, and our config here expects that we're going to use that. For now, what I'm going to do is you'll see this here called isolated modules. I'm just going to comment that out for now, and that's going to fix this error for us in just a second here. There we go, that fixed that error for us. We'll bring that back in just a little bit, but that's just really used to make sure that you're using imports and exports, and pretty much any project uses them, so that's why they have it there by default. So this right here is going to give us an HTML element. Let's make sure we get the rest of our elements. As we can see, if we just come over to here, we have our new task form. So I'm going to copy that over, and we're going to see that we have our new task title, and I'm going to copy that in as well. I'm going to make sure I call this a form, and this is going to be our input. So now when we save, we have our list, form, and input. And if I hover over these, you'll see that it gives me a type. It's saying, hey, this list has a type of HTML element, which is called element or null. So it's either an element or it is nothing. But we want to be a little bit more specific because we know that this list is supposed to be a UL. So what we can do is when we call query selector, we can pass it in what's called a type. And this type comes inside of these angle brackets here right after the function, but before you call the function. And not all functions accept angle brackets, but some do. Any function that uses generics is going to accept these. And we can actually see that if we just hover over query selector, you're going to see up here inside the angle brackets, it defaults to element, but we can specify anything we want inside of here. For example, we can say, you know what, this is going to be a uList element. And now when we save and we hover over this function, you can now see that it's using this uList element. So now our list, when we hover over it, has that specific type of HTML uList element or null, which means that it's going to have all of the properties and so on defined on a list. Or for example, on our form, we can make this an HTML form element. And this is going to do the exact same thing. Now our form here is an HTML form element, so it knows all the things to do with forms, and we can do finally the same thing with an input. So we can say HTML input element. So now when we type in input.value, you can see it has that value right there. While if we type list.value, you'll see that there is no option for value. This is really useful since now TypeScript knows what the types of all of these are, and it makes it so much easier to work with HTML elements. Now I did mention that not every function has this generic syntax you can add onto it. And for example, if I wanted to get an element by ID, I can't pass in this form element here. This is just not valid TypeScript. So what I need to do instead is tell my TypeScript that this thing returned by getElementById is not just an HTML element, but is specifically a form. So when I save, if I come over here, I can say as, and then I can actually tell it exactly what this is. So I could say, hey, you know what? This is an HTML form element. So what this code does is it says, okay, this thing right here returns something. In our case, it is specifically returning an HTML element. And I'm telling TypeScript, you know what? This thing right here should be the type of HTML form element. So now when I hover my form, you can see it has that type of HTML form element. And generally, when you get element by ID, it could be an HTML element or null. So we can come in here and say or null. And now what this is saying is, hey, we're either going to get a form element or it's going to be null if nothing with this ID exists. And as you can see over here, we have that exact type. So this right here is a lot of talk, essentially to create three things, but it's really important that you understand how all these different things work. Now the next section that I want to talk about is how we can create the event listener for our form. So that's pretty simple. We can do form.addEventListener. This is going to be the submit event, and we can take in that E object. And by default, I just want to prevent the default on this so that we don't accidentally refresh our page. And then from here, what I want to do is I want to get the value from my input. I just want to make sure it has a value. So we can say if input.value is equal to an empty string, or if input.value is equal to null, then I want to return because that means we haven't typed anything in yet. But you'll notice we're getting some errors, which are kind of interesting. If we look at this, we'll see it says, hey, object is possibly null. And that's because when we do our query selector for our input right here, it's returning to us something that is either an HTML input element or something that is null, because what if nothing with this ID exists? Well, we need to take that into account. TypeScript says, hey, this thing could be null, so you need to take into account that it could be null. And the easiest way to do that is just to add a question mark right here at the end. This is called optional chaining. I have a full video covering it. I'll link in the cards and description for you. But essentially what it's saying is, hey, if this thing exists, give me the value. If it doesn't, return undefined. That's all this code does. So now we're saying, hey, if we have a value that's not null and it's not equal to an empty string, continue with our code. And you'll notice something interesting. If I say input.value, you'll notice we no longer get those underlines. And that's because this code right here ensures that our input actually exists, because our input cannot be null at this point. So TypeScript knows after we get past this if statement, our input is no longer null. And you can see when we hover it, the type is no longer null at all. It just says HTML input element. So TypeScript is smart enough to actually look at your actual code and determine, okay, at this point, it is impossible for our input to be null. So we know it is no longer null. So we don't have to do the question mark checks anymore. So now let's continue on, and what we want to do is we want to create a to-do. We're just going to call it a task. So we're going to say const task is equal to, and we want to create an object, and this object is going to have an ID property. We're going to give it a title property, a completed property, which is just false, and we're also going to give it here a created at date, which is just a new date, just like that. And we can give it an ID. That ID just comes from that UUID v4 function, so we can comment this code back in, get rid of that console log, and then we can come in here with our title, which we know is just our input.value. So now we have created a task. If we hover over this, you can see that this task is defined as something that has an ID, which is anything, a title, which is a string, completed, which is a Boolean, and created at, which is a date. And the reason this ID is returning anything is because if we hover over here, you're going to see we get an error. It says could not find declaration file for this module. Essentially, we cannot find any types for this module UUID. And that's because not every single library written inside of Node modules has types or is written in TypeScript. So what you need to do is potentially download those types if they exist somewhere else. Lots of really popular libraries that don't have types built in are going to have a separate library you can install with those types. If we hover this again, you'll see down here it says try npm i-save dev types UUID. And that's because every library that has types written for it outside of the library itself is going to come under this @types umbrella. So if we go back here and we just paste this code, hit enter, what this is going to do is it's going to check to see if there are types for this library that someone else wrote that is not the library maintainer. And that's just, again, because not all libraries have types built into them, so people have to build their types on top of it. Now, most popular libraries are going to have types, and if they don't, they're going to have this type declaration you can use. But if you do run into a library that doesn't have types and there are no type declarations already available, you need to just write your own types or admit that you just have to deal with the errors inside your TypeScript. So now if we save, we can go to our package.json. You can see we now have types for that UUID inside of here. And if we go over here, we hover over this, we should no longer be getting this error. It should be disappearing here soon because we now have those types. I can just try deleting this, typing it back in, see if that gets rid of the error. There it does. So now we have types, and if we hover our task, you can see our ID is now a string, and that's because this UUID thing returns a string. While when it had no types, TypeScript didn't know what it was returning, but now that we've declared those types by installing them, TypeScript knows what it is returning. And again, you only have to do that install step if the library you're using is written in something other than TypeScript. So now the next thing I want to do is I'm just going to call a function called addListItem, and this addListItem is going to take in a new task. We'll call this new task instead of task. There we go. Now let's create that function called addListItem, which is going to take in a task, just like that. Now immediately we're going to be getting an error, and that's because when we hover this, it doesn't know what task is. So it says task implicitly has an any type, and that is something that is not allowed inside of TypeScript. You can change that in your config. There's something called implicit any. Also, we can get rid of this isolated modules, put that back in there. But there's something called implicit any that you can either set to true or false. Generally, the default, like they have it here, I like to have it as is because I want any time that there's an any to have an error be thrown. So I should specify the type for this task. And what I could do is I could say, you know what, the type for this task is an ID that's a string. It is a title, which is a string. It is going to be a completed field, which is a Boolean, and a created at, which is a date. And that is going to work. Our task has these exact properties on it, and our new task up here, they both match, so it's going to work. But a lot of times when you're defining things like this, where we're going to use tasks all over the place, it makes sense to create a custom type for this. I'm going to copy all of this, and instead I'm going to declare this as a task type. And at the top of my code, I'm just going to declare a type called task. I'm going to set it equal to this right here, which is essentially an ID with a string, a title with a string, completed at as a Boolean, and it created that is a date. Now when I scroll down here and I hover that task, you can see that it tells me all the information about a task, what it takes up essentially, and our task is just one of those task objects. So we created this type called task, and we declared our task variable as that specific type. And even though we didn't declare this as a task up here, since they have the exact same properties, it doesn't matter. TypeScript is smart enough to know that, hey, this object has all the same properties as a task, so we're just going to assume it is a task, even though it's not specifically declared as one. If I want to declare this as a task, I can just put a colon here, type in task after the variable name, and now this thing is actually a task object, and it knows that it is a task object. And so for the most part, I like to declare my variables as specific types if they have specific types defined for them up here. So now let's create this add list item function. This function is going to be pretty easy to understand because it's mostly just JavaScript. First, what I want to do is I want to get an item. So this item is just going to be an li, so we can say document.create element, which is an li. And we click save, we hover the item, you'll see it is an HTML li element. And the reason it's returning an HTML li element is because TypeScript is smart enough to know that we passed an li into create element, so it knows that this should be an li element being returned, which is really handy in my opinion. Now, something else that I want to do is I want to create a label. So I can say the label is document.create element of label, and I'm also going to create a checkbox as well, and this is just going to be an input. And we want to set the type for our text box here to checkbox. There we go. And now we essentially just need to combine all these different things together. So what I want to do is I want to say that our label is going to have inside of it our checkbox, and I also want to take our task.title and append that into our label as well. So our label is going to have the checkbox element as well as the title that comes after that. And then what I want to do is I want to take my item and I want to append my label into that. And then finally, I want to take my list and I want to append the item, sorry, there we go. And you'll notice here again, this question mark syntax is always being automatically applied because this list could be null. So if it is null, we want to make sure we take that into account so we don't get any unexpected errors. So now with all of that written, I can click save, and now we have this all set up. So I can type in test, hit enter, and you can see that that is added right here for us. Now, obviously the checking and unchecking doesn't really do anything. It doesn't toggle anything, but we have this working as we expect. That's really cool. We are first step done. Now, if I hover over this add list item, you'll see this add list item is a function that takes in a task and returns void. That essentially just means that it returns nothing. And this is because we're not using a return anywhere in here. If I did say like return true, for example, and I hover add list item, you now see that it returns a Boolean. And this is automatically inferred. TypeScript is smart enough to know that this returns a Boolean because of the return we have down here. So I don't even have to define the return if I don't want, but I could come in here and explicitly say that it returns a Boolean. And then if I try to return something like a number, it's going to give me an error and say, hey, you're returning a number and we expect this to be a Boolean. So that's really handy, but honestly, we don't care about that because we don't have any returns. Now, another thing I want to make sure we do is I want to take our checkbox. I want to set the checked flag equal to our task.completed. And that's just because if our task is already completed, for example, if we pass this as true, I want our checkbox to be checked by default. And as you can see, it's checked when we have it as true. Change this to false. When we type something and hit add, you can see it's not checked. So that's working as we expect. And the next thing I want to do inside of here is I want to clear out my label. So we can say input dot value equals empty string. So now when I enter something, it's going to clear this out so I can type something else inside of it. Now the final thing I want to do with this to-do list to really make it perfect is to save all of the information to local storage so we can access the information later, come back, and it's still going to be there. So what I want to do is I want to create a variable that's going to contain our tasks. We're just going to call this tasks. And this is going to be an array of tasks that's by default an empty array. And what we want to do is define this as a type. So what we can do is this is going to be a task array. So to define an array in TypeScript, we just give it the type that we want, and then you put the array symbol at the end. And when we hover here, you can see that this is an array of different task items. So now TypeScript is smart enough to know that this is an array, so it has all the array methods, and each element inside of it is a task. Now what I can do is I can say down here, tasks.push our new task, and that's going to work just fine. But if I try to take my task and I try to push in something like a Boolean, which is not obviously a task, I'm going to get an error that's saying, hey, this is a Boolean, we expected this to be a task. Again, one more reason TypeScript is super amazing. So now we're pushing our task into our list. Now I want to make it so when we toggle our checkbox, it's also going to update in our list. So down here, we can just add an event listener for our checkbox. Add event listener on change. And all this is going to do is just going to take our task.completed, and it's going to set that to checkbox.checked. So now every time we change our checkbox, it's going to change the completed flag in our task. So if we just come and we console log, for example, our tasks, that's going to get all of our tasks. If I inspect our page here, go to the console, I can create a task, and now when I toggle my checkbox, you can see that it's printing it out. So the first time I toggled it, completed is false, and then when I toggle it the second time, completed is false again. But here, if I toggle it, we'll see completed is true. There we go. And I toggle it again, completed is going to be false. Perfect. So now the next thing I want to do is I want to make it so we can save these to local storage and get them out of local storage. So pretty simple to do. We just need to create a save function. So I'm going to call this save tasks, and we're going to create a function called save tasks. And this is just going to take local storage. It's going to set an item. We're going to just call it tasks. And it's just going to stringify our tasks. So now every single time that we check a checkbox or whenever we add a task, we're going to save those tasks to local storage. And then we're going to create a load tasks function. And this load tasks function, what it's going to do is it's going to get from local storage our item, which is the tasks item. And we want to parse this into a JSON object. So we can say json.parse. Just like this, and then we want to return this value. But immediately you're noticing we're going to get an error. If we hover over this error, it'll essentially tell us, hey, you know what? We're passing in an argument of string or null, and that's because this local storage get item returns string or null, and JSON parse only accepts string. So if this is null, it's going to throw an error, and that's essentially what this TypeScript error is saying. What we can do is we can just extract this out, and we can just say, right here, what we want to do is we want to get our task JSON is equal to that, and then if our task JSON is equal to null, then we can return an empty array. Otherwise, we're going to parse out our task JSON. And now when I hover this load task, you're going to see that it's returning to us any. It's returning any value, and that's because we don't know what it could return, because JSON parse, if we hover over this, it just returns any, because JSON parse could parse to literally anything at all. So what we want to do is we want to explicitly define what we're returning. We're returning an array of tasks. So now when we hover over load task, you can see it's explicitly returning an array of tasks. So when we use this, we'll know that this is an array of tasks. And this JSON parse is always going to parse out to an array of tasks. So all the way at the top of our page, we can just call that load tasks function. And then for each one of our tasks, we just want to render it to our page. So we can say for each task, what we want to do is we want to use that function, which we called add list item, just like that. Now when I save, you can see we get a bunch of information being populated because I had all this in my local storage by default when I was testing. If we just get rid of that though, we come in here, we can just clear all that out. Now I refresh, I type something in, hit enter, type something else in. I'm going to check one of these. Now I refresh my page. They're all stored inside of it. Now, if you're still unsure of if you should use TypeScript, you want to check out this video linked over here where I talk about when TypeScript is good, when it's bad, why you should use it, and why you shouldn't use it. Also, if you want more TypeScript tutorials from me, please let me know down in the comments below. I really enjoy TypeScript and would love to teach more of it. With that said, thank you very much for watching and have a good day.